time Fourier transform with a window having the both facility of dilation. Dilation means it will expand or contract, and simultaneously translation. Okay, so that's why the window is written. You see Wt minus tau with a dilation factor d. I'll just simply show you a little bit of the dilation. Now see, आप खुद करो ना mathematics. Suppose you have a signal, see, xt. So from 0 to minus 1 it is something like that. 0 to 1 it has a constant value. Then 1 to 2 it has a. If I write xt by 2, what will happen? So when I take minus 2, if it is a xt by 2, now this is xt. xt means the value when t equal to minus 1, xt 0. When t equal to 0, xt 1. T equal to 1, xt is 1. T equal to 2, xt is 0. So if I write xt by 2, a function just t divided by 2. So now see, when my t will be minus 2, so minus 2 by 2 is minus 1, x of minus 1 is, likewise it will be minus 2, 0. So it starts from 0, now like this. What happens to the waveform? What happens to the waveform? The waveform gets expanded. But here one problem. One problem. Suppose I have a waveform of this. Let us say square window. I am taking this of magnitude 1. If I expand it, now it is expanding like this. See in this case, is its height is changing? Its height is not changing. So the energy becomes double, triple. But if you want to keep the energy constant, because the wavelet basic is you have to keep it is a wavelet, all the energies will be remain constant. So there are two property of the wavelet. One is the admissibility, its energy must be remain constant. So if you want to keep the energy constant, then what will happen? Then see, if this is your initial wave, that is known as the mother wavelet, the main wavelet. If you are dilating it, okay, so now when it will expand, its magnitude will become higher. When it will further contract, its magnitude will be double. So in the time frequency plane which we were talking of earlier, see, just I am giving one simple example. This is the time, this is the frequency. The Fourier transform, what is the time of the time? Time is nothing but the total length of the signal. The time of the window is equal to the total length of the signal. Fourier. So this is the time frequency plane, and you are getting a better frequency resolution. The more we have seen that 10 cycles you are taking, frequency resolution is 5 Hz, very accurate frequency resolution. So the more number of cycles of the signal you are taking, frequency resolution is better. Okay. In STFD, what is the thing? Short-time Fourier transform, you are taking the window of a fixed width, isn't it? So suppose you are taking a window of this width, half of this. So you are calculating FFT for this, FFT for this, like FFT for this, FFT for this. So these are the just square tiles fitted. But in wavelength, this wave or the window is changing at different levels. That level is resolution level, or we term that as a scale. अब जैसे म्यूजिक होता है ना, different scale note, very high note, then come to lower note, then come to lower note. So these are the frequencies. So in this wavelet, these are the basis of the known as the basis of the wavelet. One is the mother wavelet, then you generate the daughter wavelets by means of dilation, and why you are making translation? To cover the whole length of the signal. But the major fact here is the dilation. We are filtering the water. Suppose you are getting some muddy water from the pond. So how to get pure water? So you first pass it through charcoal. This is a filter of different length, filter characteristics. Then you pass it through sand. Then you pass it through something. Finally you are getting pure water. So the wavelet can be treated as a filter bank. It is not a single filter having one cutoff frequency. These constitutes different filters, or these are the filters at different bands. Are you clear? So that is the concept of the wavelet transform. Then we particularly myself and few of my students, we are working on a new concept that is on the generalized S transform, the new technique. Just I am telling you about basically a wavelet, same as wavelet. This technique was developed by one of the geophysics man, Stockwell, and another is Lalu Mansingh. You might have heard the name of Lalit Mansingh, who was the High Commissioner to British. Fortunately, USA and Britain also. He was one Odia fellow. Elder brother Lalu Mansingh. So they have developed this particular technique for the application of the S transform. It is a technique to seismic signal. Seismic signal, you might have known that the seismology, all these things. So we incorporated this particular. So that is the major emphasis. We have attended one of the national conference where Professor Lalu Mansingh was presenting this particular topic. So we took into that and applied. My whole PhD thesis is on this particular S transform. Okay, so here only thing is what we are doing, the window which is taken by the wavelet transform is depend on different scales. So here what we do, we change the window according to the frequency of the signal. Suppose your signal is of very high frequency, F is high. If you are choosing a window width reciprocal to the frequency, then what will happen? For very high frequency, what will be your window length? Very low. So see, in your signal, if there is a very high frequency, what is the time period? Very small, and it will vanish immediately. So to capture that, you require a window of very small length. If your signal is of low frequency means time period is large. So that is the main concept. If the time period is large, at least एक cycle आने तक you have to take more signals. So here the only modification of wavelet is that in wavelet the window width is changed according to a scale 2 to the power j. But here it is inverse to the frequency. The more will be the frequency, the narrower will be the window width. That is the simple concept of the this S transform. This is the discrete version. These are the interpretation of some, because I am working in the power quality domain. If anybody of electrical are there, we are applying this S transform as well as the wavelet transform to different non-stationary power signals. So these are just for a given hints to you. Then we will go to the other things. See, this is the transient and all other things we have discussed. This is another. You see the beautifulness of this one. Although there is a very low transient present for a small time, that can be easily captured by the means of this. Okay, by means of this wavelet transform or S transform. Next we will go to the next chapter. So now at least you have got some idea about the signal processing technique. Now the problem is, depending upon your nature of the signal, in which signal you are working, you have applied a particular suitable signal processing technique, either Fourier transform or wavelet transform or subtime Fourier transform or S transform or Wigner-Villay distribution or there is a Hilbert-Huang transform. So many signal processing techniques are there, but there is no time to discuss all these signal processing techniques. Every technique having its own merit and limit. Clear? So the prime objective of these signal processing techniques is to extract hidden important information from the signal, because I want to extract different information. Somebody is working on the speech signal analysis, whether a letter O is spelled by a kid or by a young man or by a young woman or by a old man, old woman, although the letter is O, but if you are taking the speech signal for analysis, in different case the signal appears different. But ultimately the result is O, whether it is told by any person. So these are applicable for the speech analysis also, if you want to characterize the speech. Similarly, people use all these techniques also for the image analysis, image processing. You want to fingerprint identification. We are also doing a little bit work on the bioinformatics. Suppose for the fingerprint, so whether I am pressing my finger very firmly or slowly or whatever, so how can it be identified? Photograph face identification. You are taking a photograph of mine from the front or from the side or from anywhere, but it should be identified. And recently we are working with one of the professors from Jadavpur University on emotion recognition. How to recognize the emotion, whether somebody is in sad or somebody somebody is in sorrow. So that recognition we are doing from the eyebrow movement, lip movement and facial expression. So there are a lot of scope on this recent area of working where signal processing can be used as a tool. But my dear friends, you have to choose the right tool for the right application. The necklace, as I have told you somebody earlier yesterday, the necklace is to be worn on the neck but not on the foot. So you have to understand your problem, then design a suitable necklace for that. Okay, then put it on the neck. Don't put the good, beautiful golden necklace to a old lady, but to a beautiful young lady. Okay, so you have to identify your area of research first. Then you have to put your ornaments. Subcomputing, neural network, fuzzy logic, these are the ornaments. But proper ornament is to be chosen and to be kept in proper place. Then nowadays it is a hybridization, सब बोलते हैं कुछ hybrid करके एक paper निकालते हैं. But for hybridization again also you have to see, don't put rasgulla in rice. You have to put dal in rice. Isn't it? So if you put rasgulla in rice, you see both are beautiful things. Rice is beautiful, rasgulla is so beautiful. But they have suitable time. One is to be taken as a dessert, one to be taken as a main food. So don't hybridize these two, but you have to hybridize rice with dal or chapati with dal. So which technique are well suited for hybridization? That again you have to see. Okay? Don't think that okay, so many techniques are available, I can hybridize something, do something or that. Fine? Okay, let's go to the next. So now I have some important informations, I have some important features which have been derived by using suitable signal processing technique to my ROS. What is the next step? Classification. I have to classify whether I am in a sorrow mood or not. I have to classify whether he is in a happy mood or not. I have to classify whether this fingerprint is of Mr. X or not for authentication. I have to classify whether my machine from which I have captured all the signals is in a good health or not. I have to test whether the ECG signal which is taken from my patient, is it pointing to any defect in his heart or not. So that is the ultimate aim. Okay. So for that we require a classification technique. Fine. So here I want to give you one modern advanced area. How you are classifying? Just tell me how you are classifying. Suppose you have a set of data. Initially, with known set of data, you take 10 patients, take their ECG signal, take their EEG signal, then we are taking these are the ECG signal, these are the features, then it is a healthy. If these are the features, then it is not healthy. So that classification, how we are doing? By designing a suitable classifier, either a neural network classifier. Again, when you are going for a neural network classifier, there are different neural networks: probabilistic neural network, feed-forward neural network, support vector machine, Bayesian classifier, fuzzy classifier, hybrid of fuzzy and ANN. So many classifiers are there. So now we are doing a much more interest on the information fusion. What is information fusion? The simple example I can give you. Suppose I have a problem. I am going to a doctor. The doctor diagnosed me, you have a heart problem. Then definitely as a patient, I will get disturbed. ये क्या बोल दिया हार्ट प्रॉब्लम है, मैं तो आज तक से अच्छा पढ़ा रहा हूँ, अच्छा क्लास में लेक्चर दे रहा हूँ, what is the problem? Then what will you do? So Dr. X, who diagnosed you, taking certain samples from you, he may take your ECG, he may take your blood sample, some information he has taken. Based on that information, he classifies that you have a heart problem. Fine? Then you are not satisfied, you go to Dr. A. Why? Then what Dr. Y does? Again, वो ECG क्या हुआ था मेरे को पता नहीं. Again he goes from ECG, so he goes for all the tests. He tries to extract the important information. Now he tells you, you don't have any problem. Because now one classifier, suppose probabilistic neural network, tells there is a problem. Another classifier, feed-forward neural network, tells there is no problem. Then what is your diagnosis? Dr. X बोलता है you have problem, Dr. Y बोलता है you don't have any problem. Then how will you satisfy मेरे को क्या हुआ है? Then you will go to Dr. Z, another classifier. वो tells 50-50. Because see, sometimes the information which we are getting are not quantified. Dr. X tells 1, it is a digital circuit, yes, 1. Second tells 0. Third one tells 50-50, may or may not. Because sometimes the information which we are getting, which we are retrieving, are not purely quantified, it is a fuzzy sense, 50-50. Then what is your interpretation? कितना जाओगे, कितने लोगों के पास? So that is a new area of research nowadays. People are doing information fusion. How to gather the information from different sources, fuse it to get a final decision making process. That's why this is a new area, information fusion, that refers to the field study of techniques attempting to merge information from disparate sources, despite differing conceptual, contextual, typographical representation. Because sometimes the features which we are getting are not quantified in terms of 1, 0 or 0.1, 0.5 is in. Some linguistic features are there, some other features are there. That's why the information fusion, pattern recognition, these are the new area of research of machine intelligence. You see, this should be added to the signal processing. Otherwise, if somebody is doing research purely on signal processing, development of the signal processor, that's another thing. But if you are doing some theoretical work on signal processing, either you have to go deeply into the mathematical analysis of all the signal processing techniques, go on doing that, or you have to hybridize something. So that is the new thing we are just doing. So I am doing just this simple aspect I am telling you. First you have the data. Okay, if you have a data, then from this data I am extracting the feature. From this feature I am now extracting the classification, which can be done by neural network, which can be done by decision tree, which can be done by support vector machine. Then the final